let's talk about the empirical rule. The empirical rule is going to allow us to use the mean as well as the standard deviation so that we can make some statement about data values. So when can we use the empirical rule? Well, this is going to be when we have distribution that is symmetrical or even approximately symmetrical. So we want to think about when we have data that has that bell shape. So I'm going to come back to this slide, and I'm going to start by first showing you what the shape in this distribution for the empirical rule is. So notice I have a bell-shaped curve here, and I have symmetry, so I can draw the mean right down the middle, and the mean is going to separate the upper half of the data from the bottom half. So because we have symmetry, we can say that we have the same percentage on both sides. So let's start with right down the center. We've got the mean in the middle, and one standard deviation above and one standard deviation below is where we say 68% of the data will lie. So the 68% is going to be with 34 below, 34 above, for a total of 68%. Now let's look at where we feel let's use this here, where we add an additional 13.5% on both sides. So if I add 13.5 to the 34% on the right, as well as 13.5% to the 34% on the left, I'm adding an additional 27%. So 27 and 68 is going to be 95%. So we say to be within 2 standard deviations of the mean is where 95% of our data lies. So 95% of that data we feel is going to be within 2 standard deviations of the mean. So that could either be above or below. Now out here in the tails is where we have that remaining like 2.35%, and that's going to be in both directions because we have the symmetry. So the rest, if we add up the 2.35 and the other 2.35, we know we get 4.7. So we get this 95% plus 4.7%, which we know is not quite 100%. So it doesn't quite equal 100%, but we know that this line here is not all the way touching in these tails. We know that this is kind of going out, and that's where we would get that last little bit. But it's within 3 standard deviations. So when we are within 3 standard deviations of the mean, we can add that additional 2.35% to the 95 on both sides. So this empirical rule is really just going to approximate percentages for where we feel the majority of our data will lie. So let's see an example with the empirical rule. So we've got that manatees are these large marine mammals, and we have this paper that talks about prediction equation of body weight of these manatee. And so they say that calves in captivity were, they studied these manatee calves, and they got some data on them that suggested reasonable values for the mean and the standard deviation for the body weight. So here is what the mean was, and here is what the standard deviation was given to be. So now what we can do is we can take what we know about the data and we can use the empirical rule to set up information on this data. So we have to note that this is only going to be if we have approximately symmetrical data. So assuming our data is approximately symmetrical, how can we set this data up in the empirical rule? Well, to start, and notice that if we go back to this slide here, this is where the breakdown of what we believe the data is based on the standard deviations under that bell-shaped curve. So we know that to be within one standard deviation of the mean would be 68% approximately of our data. Within 2 is where the 95% would lie, and within 3 would be the majority of our data, 99.7. So we can put this on a curve, and let's go ahead and do that. So I'm going to just draw it here. I know that the mean was given to be 32.9. So if I put 32.9 right down the center, I know that that is my mean mu. Now we know that 68% of our data is going to lie within one standard deviation. So I have to add one standard deviation as well as subtract one standard deviation to be above and below. Well, the standard deviation is given to be 4.8. So let's go ahead and add one standard deviation and subtract. And we get 28.1 and 37.7. So 28.1, 37.7. I now know that 68% of my data lies one standard deviation above, within one standard deviation of the mean. Now we can do two standard deviations, which we just need to add an additional 4.8 in both directions. And we see that that's going to be 23.3, 42.5, 23.3, and 42.5, pardon me, 42.5. Now, we know that 95% of the data covers all of this area here. So we add an additional 13.5% to what was already there with the 68%, and we do that in both directions. Now, to be within 3 standard deviations of the mean, we get 18.5 and 47.3. So 18.5 and 47.3. So this represents here, let's just get some black. We've got 1 standard deviation, so that's just 1 sigma, 2 sigma in blue, and 3 sigma in this fuchsia. So this is where, again, we are just putting percentages to where we believe the majority of our data will fall, which is, or not just the majority, but where chunks of our data will fall. So we know that 95% of, no, not that, that's another example. We know that in regard to these manatees, we can see that 95% of our data falls between a body weight of 23.3 kilograms and 42.5. That's that 95%. And we can answer questions on this example based off of what we know the mean is and the standard deviations are and where we believe certain percentages of our data will lie within.